one more thing to go over before starting all the examples. So this is from I don't know, 1 or 2 videos, 3 videos previous. So we were going through and we said, okay, well, we have a non-exact equation. And then we said, okay, well, we'll multiply by mu of x comma y. And then we applied the condition that the equation is exact. And we got this terrible, terrible partial differential equation that probably no one in the world can solve for most problems. All right, so then before we made an assumption that we hope that mu of x comma y is only a function of, before it was x, but it can also only be a function of y sometimes. Sometimes that works as well. So I've changed this a little bit. So now that we hope that mu of x comma y is only a function of y, so mu of x comma y is equal to mu of y. There are no x's in it. And then instead of partial mu partial y equal to 0, we have partial mu partial x equal to 0. And that also simplifies this equation. So we still have partial mu partial y here. Before it was 0 times Mars. But now we have partial mu partial y times Mars plus partial mu, plus mu times partial Mars partial y equals, this was partial mu partial x, and now we have 0 times Neptune plus mu times partial Neptune partial x. And so we'll simplify here and we'll get a very similar formula. So what I'm going to do is I'm going to take this mu and I'm going to subtract it over to the right hand side, and this piece as well, it's equivalent now to mu prime of y. There are no x's in it. We've assumed there's no x's in it. We hope it works. But that's the idea. We're going to make this mu prime of y. So now I have mu prime of y times Mars. And I'm going to move this over to the right and factor out the mu. So that's going to equal mu. And in here I have partial Neptune partial x minus partial Mars partial y. Then I'm going to divide the mu and the Mars functions. So now I'll end up with mu prime of y over mu of y is the same as partial Neptune partial x minus partial Mars partial y all over the Mars function. And so it's a little bit different. So before we had Neptune on the bottom, now we have Mars on the bottom, and we've also reversed the order of this. It used to be this partial Mars partial y was on the left, and partial Neptune partial x was subtracting on the right. Now it's reversed. But otherwise, it's a very similar formula, and from there, it's the same idea to try and solve this. And the same thing here, must only be a function of y. Of y when simplified. To work. Right, so we're taking a guess here and we're hoping it's right, but it's not necessarily going to work. And so we'll do this in some other examples where we'll try to find a integrating factor that's only a function of x, and it's not going to work out, but then we try an integrating factor that's only a function of y, and that one does work out. And in other problems, we'll actually have neither of those work, that it won't be an integrating factor that's only a function of x or only a function of y. The only one we can come up with is actually one that is a function of both x and y. And there's sometimes some tricks you can do to find those, but in general, it's very, very difficult to find it when it's fully a function of both x and y.